Ladies and gentlemen, good evening and welcome to another session of the Nambane Academy. I am so excited to be here for term 3 content, but just note that this content we actually started it uh, sometime during the holidays with the thinking of trying now to ensure and enhance the way of how we do things. With that being said, ladies and gentlemen, it allows me now to actually go back and try to explain key important concepts that has to do with a galvanic cell. But before we get into that, let me just maybe quickly greet everybody into this particular platform and those that are joining from different places. Let me quickly say, Mr. Sarami, how are you, sir? Mr. Sarami?
Evening, sir.
Evening, sir. How are you, my brother?
I'm fine, and you, sir.
I'm doing very well. Oratile?
Good evening, sir.
Thank you very much, lady. How are you?
I'm good, thank you, sir.
Thank you very much. Tapelo?
Good evening, sir.
Evening, my brother. Evening, my brother. Let's quickly have a recap only for the purpose of catching up. And remember, we are basically now working towards the completion of this particular topic. But what did we say? We said we need to understand few basic things. The very basic one that we need will be understanding key concepts, which is oxidation and now reduction. So with oxidation, we define it now as a loss of electrons. Furthermore, we define reduction as a gaining of electrons. But there's one other critical thing that we need to understand. An increase in oxidation number is also regarded as oxidation. Furthermore, the substance that is losing electrons, we call it now a reducing agent. We have a trick that we have come up with to use a formula sheet in order for us to actually be in a position of getting everything right. So I want now to take a new sheet just to explain all these concepts very quick and now with ease. The reason for that is I want us to establish a system that will now easily work for us. I know we did this, but we also need a way of saying how best can one remember all these important things in an exam. Ladies and gentlemen, let's start. We say now all the reactions that are going to take place will be redox reactions. Let me just write it there. So redox reactions basically means electron transfer. But electron transfer basically now means what? Basically means losing of electrons. Maybe I should just clean it up quickly. I am trying to summarize all this quickly. Electron transfer. Very easy. But now this electron transfer, ladies and gentlemen, we refer to it now as oxidation as well as reduction. excuse me. But what does this mean? Ladies and gentlemen, if we have a transfer of electrons, is either we have now where we say oxidation is the loss of electrons, is the loss of electrons, and reduction obviously now will be a gain of electrons. So it means we'll have a substance that is gaining electrons and a substance that is losing electrons. Furthermore, we say fine, if this substance is losing electrons, this substance we call it now a reducing agent. So a reducing agent is a substance that loses electrons. Very, very, very important. So a substance that is losing electrons, it is called a reducing agent. And this reducing agent, ladies and gentlemen, it is now further now called is oxidized. A reducing agent is oxidized. So these are critical words or statements that one must understand, because they influence how we are going to answer the questions in the exam, as well as the information that will be given to us. Furthermore, we say fine, if we have a reducing agent as a substance that loses electrons, what about now a substance that is going to gain electrons? That substance, we call it now oxidizing agent. So oxidizing agent is a substance, is now a substance that gains electrons, and this substance is reduced. So these are critical words that one must try now to look for in the exam, or explaining how and when will a substance start gaining electrons. So these are the basic ones that we all need to start thinking and knowing of. So a substance, when we refer to a substance, we refer to a substance that gains electrons as an oxidizing agent. Furthermore, we say fine, if we have this now substance, what else can one use in order to identify oxidation and reduction? Why? Because everything will be now based on oxidation and reduction reaction. So it is very, 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 very important. So if one cannot be in a position of identifying an oxidation reaction or a reduction reaction, ladies and gentlemen, we are going to not have the correct answers or even have the correct approach thereof. So this says to me, there is another way that one can say oxidation is an increase in oxidation number. This will be understood better when we have a substance that we see that now, but we are going to have an increase in oxidation number. So how do we basically refer to this one? We use, while I am looking for a substance that is going to gain electrons or lose electrons, there should be a way of me saying how best can I identify this particular substance thereof. This will be done easily when one is using table 4b. So I am not sure if on your screen you can basically see table 4b. Let me just confirm, Mr. Serame, can you see table 4b?
Yes, I can see it, sir.
Thank you very much. So what we do is we use this C method. Let me just highlight it. We use this C method in order for us to identify which substance is actually going to have now or undergo oxidation. We say the ones at the top will undergo oxidation, the ones at the bottom will undergo reduction. It's very important. Why is it important, ladies and gentlemen? Everything based on the electrochemistry, it is focusing on oxidation and reduction, Hafsen. If we are unable to identify that, ladies and gentlemen, we are going to have a lot of problems. Let's go back to this slide of summarizing everything. We explain now to say, fine, what about now oxidation? Oxidation, we say there is a decrease, is a decrease in oxidation number. So maybe I should just quickly explain that. Okay, fine, what does this mean basically? This means I will have B plus 1 electron giving me B. So the oxidation number here, it is a plus 1 moving now to neutral, which is now just 0. That is the reason why we say we are going to have now a decrease in oxidation number. It is moving from a plus 1 moving to 0. So the fact that it is moving to 0, ladies and gentlemen, it basically says fine, then we are referring to or reduction reaction. So regardless of what the examiner gives me, the fact that I am able to see but I am moving from a plus 2 to a plus 1 or from a plus 3 to 0, it basically says that is a way of identifying a reduction reaction, or the substance that is actually gaining the electrons. If I am unable to do that, believe you me, everything will be incorrect, because the ground and the foundation is based on oxidation and reduction. But what about oxidation? Ladies and gentlemen, it will start from A and move now to A plus an electron. So we are starting from 0, it moves now to a plus 1. So all this here is basically us saying an increase in the oxidation number. So that is another way of one identifying oxidation reaction. And that is another way of saying I need somehow to be able to identify a reduction half cell as well as oxidation half cell. Ladies and gentlemen, let me maybe still on the same slide introduce this equation. E naught is equals to E cathode minus E anode. I will explain that further. The very same reaction can be written as E reduction minus E oxidation, and E oxidizing agent minus E reducing agent. What does this say to me, ladies and gentlemen? It says this can be a trick that I can use in an exam, in order for me to actually understand everything. If I am told now that, or I am able to identify my oxidation reaction, I will know that that oxidation reaction, the substance that is losing that electron, we call it a reducing agent. Now an electrode, thank you very much. The electrode, this now an electrode. We'll explain now what is an electrode. This electrode here, ladies and gentlemen, very easy. The electrode in which oxidation takes place, it is called anode. The electrode in which reduction takes place, it is called cathode. And now one must always ask, ladies and gentlemen, what happens in a situation where I am told now which one is cathode, which one is anode? It becomes very easy. Let's check. I'm going to add a plus here just to indicate that cathode is always positive. Only when we refer to a galvanic cell, of course. And there's a negative already there next to the anode. So anode will be negative. So these are hints and tricks that one can use in an exam. So cathode is a positive electrode. And at cathode, reduction takes place, and the substance that is losing or that is gaining electrons, we call it now an oxidizing agent. There is a negative next to the anode. That negative basically says now, as we use our tricks, the negative electrode will be our anode. And at anode, we are going to have oxidation taking place, and a substance that is losing electrons, we call it now a reducing agent. That is very, 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 very important, ladies and gentlemen. Very, very, very important. So with that being said, I'm going now to give you your 30 seconds to digest all this important information, and then we will expand and build on other things. Thank you very much. I don't see any questions. Maybe it's just an indication that we can basically go now and explain more on the galvanic cell, ladies and gentlemen. I am only doing this for the purpose of a refresh course, or a refresh idea, such that we do not lose each other, and we know that now we are happy in terms of everything that we do. Let me try and create a cell which will be a galvanic cell. Let's see if it will build out nicely. Let's put it there, and let's take another one, put it there. Let's rotate this one. And bring this one closer. There we go. And increase this one. Let's fill this one with that, and this one with that. Or maybe two different solutions. Let's add green for the purpose of explanation. Thank you. And we need now an electrode. We need now an electrode. Let's have a rectangle, fill it with black. Rectangle, fill with black. Another rectangle, fill with black. And then you just need connecting wires. Let's move there. You, and we can add now our V, which is just a voltmeter. Ladies and gentlemen, this, let's label it quickly so that we understand. This here we call an electrode. This here we call an electrolyte, and then that there will be our voltmeter, and this nice bridge here, we call it now salt bridge. And this, we say, it's actually called a galvanic cell. It's actually called a galvanic cell. Now, there are things that one must understand. Galvanic cell is defined as a cell in which chemical energy is converted into electrical energy. Let's write it down. 1, or A, we have energy conversion. Energy conversion. This is very, very important. Chemical energy is converted to electrical energy. Very, very, very important. B, we also have what we call an electrolyte. An electrolyte is just now a solution, that conducts electricity through movement of ions. Very, very important. And then C, we have a salt bridge, and the functions of salt bridge is to complete the cell. The other one ensures electrical neutrality of the solutions. So now in this we have KNO3, of which we'll explain when we do further examples as to where will your cations move as well as your anions thereof. Very, very, very important. But now, ladies and gentlemen, we have what we call standard potentials, standard operating conditions. So this cell will work under specific or standard operating conditions. We must emphasize that to say, one, we have concentration, and this concentration must be 1 mole per decimeter cubed. So in an exam, what must happen? You must tell us concentration is equals to 1 mole per decimeter cubed. Correct value, which is 1 mole, and the correct SI unit. If you do not do that, then automatically you lose a mark. 2 is temperature, which must be now equals to 25 degrees Celsius. The third one will be pressure, and this pressure must be equals to 101,3 kilopascal. Very, very, very important, ladies and gentlemen. If you do not write the correct SI unit, believe you me, you are going now to lose the marks. It's very, very key and critical for that matter, ladies and gentlemen. Then we have E, what we call cell potential. And cell potential is the maximum potential difference that the cell can deliver when all the chemical potential energy is converted to electrical energy. Very important. So let's highlight key important things here as the maximum potential difference that the cell can deliver when all the chemical potential energy is converted now to electrical energy. So this is very important, ladies and gentlemen, to actually understand. We will talk of F, which is now factors that will affect cell potential, but that I want us to do it in a form of a question, in a form of how it is assessed in the exam, as well as how best can one be able now to understand the link between the galvanic cell as well as the Le Chatelier's principle. But now we can be able to say, let's go to F, and F we introduce what we call now the cell notation. So the cell notation will be easily understood when one understands that there is a form or there is a pattern that each and every one of us must use. Ladies and gentlemen, I usually say, let's have our reducing agent, and we have our border, and this border will be now our oxidized species, our oxidized species will explain now, have a salt bridge, have now the oxidizing agent. Hence it is important now to identify which one is oxidizing agent and which one is reducing agent. Then we have our reduced species. Then I usually put this line here, ladies and gentlemen, but most people, when I put that line, they become a little bit confused. So I am going to leave it as this. The reason being, once we work with a gas, it will be easy now to actually follow up the sequence of using this particular formula. So it is easy for one to say reducing agent. Where do we find that? It will be now at anode stroke oxidized species. That will be now anode electrolyte. Salt bridge, let me maybe write it down. This is now our salt bridge, and we have now our cathode electrolyte, and we have now our cathode, which will be just positive. But now the question will be, what do these lines now basically represent? Ladies and gentlemen, this represent what we call phase border. Phase borders is very important for us to understand. Maybe one thing that I must emphasize is when we work with pressure, this is now only for gases, gases only. I felt that it is needed, even though this topic was done over the holidays as part of our virtual camp. I felt that it is important now for us to actually look into it again, have this proper summary, because what I have learned is we are getting into term 3 where everything will now be more complex and we are rushing against time. So I thought, let me give you now this nice summarized version of the notes that you can easily go to and refer to. Ladies and gentlemen, with that being said, let me give you your 30 seconds for you to digest everything here, and then we will move, because now it seems like we only have, it's 1916, so it basically says we should finish now at exactly 12:30. Thank you very much, ladies and gentlemen. With that being said, now it means one must just easily go into explaining table 4b, because table 4b is the most important table that we are going to need. Why table 4b, ladies and gentlemen? Table 4b, because table 4b actually assist us to get the correct equation or the correct half reaction. So let's move. If I am going to compare aluminium and copper, maybe I should just delete this for the purpose of explanation. Let's highlight what we are going to use. It's aluminium and copper 2+. Now the one at the top, ladies and gentlemen, we say it will undergo oxidation. The one at the bottom will undergo reduction. So how do we go about writing this one? We follow that C method we spoke about, to say I must write now my oxidation from right to left, and then reduction from left to right. But it is critical also now to have a balance in the number of electrons. Do not omit the negative on the electrons. Do not omit the positives or the negatives on the charge. It is very, very important also. Then you write your oxidation half cell or half reaction, and this now also you will be in a position to check yourself. From where? From the definition itself, that oxidation is an increase in oxidation number. So you must move from a smaller number to a bigger number. Then you will know that you have actually wrote the correct oxidation half reaction. And you'll be able also to identify your reducing agent as that substance that is going to lose electrons. Furthermore, you write your reduction half reaction, and your reduction half reaction must move now from a higher oxidation number to a smaller oxidation number. That becomes now an oxidizing agent, which will be Cu2 plus, moving to 0. That will be a decrease in oxidation number. So for us to write the overall net reaction or the net reaction, we just consider our substances not including the electrons. So immediately when you include the electrons, you will be penalized. So we do not include the electrons, but we actually include the coefficients that we used for us to balance these reactions. So once I have balanced my electrons, ladies and gentlemen, it will be easy for one to note that the reaction is balanced. So we focus on balancing the electrons. How do you balance the electrons? You just multiply by the factor that is going to give you the same number of electrons. So this is very, very, very important and critical to note. Then once I have my overall net cell, I can write that cell notation. Remember, cell notation says I must have now salt bridge, have a phase border. Let's have salt bridge, phase border, phase border. So this will be easy, ladies and gentlemen. It's just aluminium because of oxidation. Remember we said now this side represents oxidation, and then I'm going to have aluminium 3 plus, then I'm going to have now Cu2 plus, and only have Cu. Ladies and gentlemen, that will be our cell notation. It becomes easy provided that I have identified the correct oxidation half cell. I have also identified the correct reduction half cell. So that is now based on what? On the information that is given. Once that is okay and I am happy with that, there won't be any challenges relating to all this. So ladies and gentlemen, just be on the lookout for these critical issues and this critical information. I wanted us to go to exam type of questions, but I realized no, we should not go there yet, because I felt that even though this was done, there's still a room now for us to actually improve, as well as what's the word, enhance the quality that was shared earlier on. So ladies and gentlemen, it is exactly 9:24. So I'm just quickly going to say, when you get the e-notes, it will be up to page 7. So page 7 will be an exercise that we are going to do tomorrow. So you have this exercise. Kindly send your answers to me before 5 o'clock, such that we can now tomorrow discuss the exam type of questions. It will only be now in 2 days, 3 days, and then we'll know that we are finished with this particular topic. We can move to an electrolytic cell. With that being said, let me quickly check Oratile, inputs please.
No, sir, everything is fine.
Thank you very much. Tapelo.
Yes, I'm complete with everything. I'm okay.
Thank you very much. Mr. Sekui, welcome, sir. You had a lot of things to do over the holidays, so hence I understood that we cannot move forward before actually trying to explain everything in detail and have now the summary that one can easily use. Inputs, Mr. Sekui, and how are you, sir?
Some good, sir. Sir, there is some that I don't understand, but
Mm.
I'll watch the e-notes, then I'll see if I'll understand them. But I'll ask questions on you, sir, so I could understand them.
Thank you very much, Mr. Sekui. Mr. Shoni Srame, kindly close it for us, sir.
No, sir, I'm good, sir.
Thank you very much. Ladies and gentlemen, let's meet tomorrow at exactly 18:30 and we'll do now exam type of questions. I will do one where I explain the concepts and now try to interlink everything that we have done today. Ladies and gentlemen, from me to you, thank you very much and have a lovely day.
Mm.